Mark Scythian, October 23rd, 2023. So in this video, we are going to solve a DC series parallel electrical circuit, solving for voltage, current, and power across all resistors. So it should be known that with DC or direct current electricity or electrons flow from positive to negative. So that means we start always from the positive terminal and we trace the electricity flow, which will initially flow on the series pathway where R1 is, and then flow down to R2 and go back to the ground. The remaining DC electrical power will continue to flow from the positive down the adjacent series pathway and then follow the same series to parallel series back to ground, and then the remaining DC power will continue to flow on series and go back to ground. So that's how all of these DC electrical circuits should start with respect to their interpretation. Next, series electrical pathways, such as these horizontal pathways, these will remain constant current. The very definition of a series electrical pathway is a pathway with constant current. So regardless to what is connected to the series pathway, its current is held constant. So the purpose of a series resistor such as R1 is to reduce voltage by accessing Ohm's law. E, voltage, DC voltage, E is equal to DC current, amperes, I, times resistance, ohms. So that being said, this circuit is measured as having a total current of 1.09 amps. So that means if we start from the positive terminal, we know 1.09 amps I multiplied times R1, resistor 1's value 8 ohms, will be 1.09 amps times 8 ohms, resulting in an 8.72 volt drop. So R1 across its resistor is absorbing 8.72 volts. This means that the remaining voltage from the source, it will subtract 8.72 volts from 36 volts and then flow to parallel R2. So 36 minus 8.72 volts. So R2 now has 27.28 volts. When we're dealing with a parallel circuit such as R2, we now divide the voltage into the resistance to compute the current draw, or the current extracted at R2. So that is equal to 27.28 volts divided into 50 ohms. 0.55 amps are extracted at resistor 2. However, we said that current remains constant on series. That is, unless a parallel circuit junction takes away amperes from the given series pathway. So in this case, R2 subtracts 0.55 amps from 1.09 amps and leaves 0.54 amps to flow down series. However, we have to be careful because we also have a corresponding or mirror series resistor at R6 also drawing 0.54 amps across its series constant current pathway. So this will then incur another voltage drop equal to 0.54 amps times 4.5 ohms or 2.43 volts. So then we subtract 2.43 volts from 27.28. This then leaves 24.85 volts to flow to R3. Again, we divide the voltage at R3 into the resistance value of R3, and R3 will extract 0.28 amps. This then takes away from 0.54 amps and leaves us with 0.26 amps flowing to R4, which when multiplied times 15.5 ohms will drop 4.03 volts. This then will leave us with 20.82 volts because we subtract the 4.03 volts from 24.85. Thereafter, R5 continues with R4 in series, as it is the junction circuit, so it behaves as a series, not a parallel, in series with R4. So therefore, since the current remains constant, it's 0.26 amps times 76 ohms, and so R5 will drop an additional 19.76 volts, and this leaves us with 1.06 volts, which then flows back to ground. We've already have counted the corresponding or mirror pathway to ground series R6, which also incurs the same corresponding current as its opposite side. So all that's left now is to compute the DC electrical power absorbed across each resistor, and that is simply multiplying the current I times the voltage V or E. So we start with R1, we have 1.09 amps times 8.72 volts drop, 9.5 watts at R1, 0.55 amps at R2 times 27.28 volts, 15 watts at R2. R6, 0.54 amps times a voltage drop of 2.43 volts. So R6 has 1.3 watts. R3 is 0.28 amps times 24.85 volts, or 6.96 watts at R3, 0.26 amps times a voltage drop of 4.03 volts drop at R4, so 1.05 watts. And then lastly, we have the 0.26 amps multiplied times a voltage drop of 19.76 volts. So R5 has a power absorbed across it of 5.14 watts.